Hello, everyone. Welcome to another episode of the Wimper podcast where we talk about all the goofy stuff related to space, astronomy, tech, AI, and a lot more to learn about which you won't find much in a conventional form of education. On today's episode of the Space Podcast, we are excited to welcome a very special guest, the founder of Seek in Space, a NASA citizen scientist, author, researcher, and science communicator. With a background in computational astronomy and theoretical physics and astrophysics, mathematics, and proficiency in Python programming and artificial intelligence, our guest brings a wealth of expertise to the table. They have devoted their career to exploring the mysteries of the cosmos and sharing their findings with the world through their research, writing, and also outreach. So, join us as we delve into the fascinating world of space, science, and we have our guest, Anushka Sharad, on the show. Hope you enjoy it. Yeah,
Yeah, yeah.
yeah. Yep. Hi, everyone. Welcome to another episode. We have Anushka Sharad here. As I've introduced her to you, so how are you feeling? I mean, not how you're feeling. How is it going? How's your day? How has your day been?
Right. Thank you so much, Divyansh, for having me here. It's been a great year, actually, because
Mhm.
I'm done with a lot of projects that I was working with, and today I got started with more projects. And at the end of this episode, we have a big announcement for your audience, which would be very much exciting. And rather
Mhm.
than that, as you mentioned earlier, I am totally into astrophysics, theoretical astrophysics to be more precise, and artificial intelligence. So I
Mhm.
foresee an integration between artificial intelligence and astrophysics, and all my projects surround around these ideas. And every day, every night, I'm just pondering over what can be done new. What is that lies beyond? Because all of us are pondering about these questions already, although striving is essential, and that is what I mostly keep on doing. Rather than that, another major aspect of my career is that empowering women in STEM and also spreading awareness about STEM fields in the society, because talking about India is mostly driven by the fields of engineering, medical, civil services, etc. But a lot of things can be done, and we do need our youth to focus on those areas as well, like astronomical sciences, space and research, development, a lot out there. So this is what I aim to do. I go to different schools, spread an outreach, meet different people. I've also been invited to an engineering college recently where I delivered a lecture about artificial intelligence and applications, and all the discussion revolved around artificial intelligence, machine learning, deep learning, data science, and whatnot. So this is how I keep on doing. I love talking about STEM, artificial intelligence, and everything that revolves around STEM. And yes, now we may move on to our questions.
Very vast sort of spectra that you have with your experience. That's great. Uh, so
Thank
like
you.
what projects have has it only been AI and astrophysics or maybe the integration of both?
Right. So
Mhm.
that's an interesting question. You know, when I was in Delhi, I was at a
Mhm.
summer program, and there we learned many things and learned many new things. And that is when I realized that we can sort of culminate all the different kinds of subjects together in order to create something new. That I'm also working on the project of astrophysics and neuroscience, because there are so many neutrons in our brain, and there are as many stars in the universe out there. So there is an intricate system in our brain, and there is also a very complex system out there in the universe. So I am discovering, trying to understand the depth of how, if we study our brain, we would be able to understand universe in a better way. So it is a sort of journey where I am discovering myself, my inner self, in order to understand the universe in a better way. Of course, artificial intelligence and astrophysics is there, but rather than that, there is astrobiology where a lot can be studied, because recently I did some astronomical or computational astronomy, and there we discovered or jotted down the data of exoplanets that we have. And when we are studying those exoplanets, it's also important to understand what biological components exist over there. Because I participated in this conference. It's in international. Wait, it's International Astronomical Congress. It would be held in Baku, Azerbaijan this year. And I presented a paper which was about SETI, or Search for Extraterrestrial Intelligence. And when I approach such a topic, it's really essential for me to understand what are those key components that I would require, or what are those major aspects, like is it some technological signatures or some bioscience, what all would be needed for me or for us to understand what lies out there, and are we alone in the universe? Because if we are alone or we are not, we need to be prepared for both the situations. But I have this strong feeling, my intuition says that I we do have someone to whom we've not met yet. And I'm trying to discover through my research paper. I presented the research paper, eagerly waiting for the decision from them. And if I get selected, I would be able to present it to a wider audience, and that would give me an exposure to more intellects, would be able to discuss or ponder about the better ideas. And all my work revolves around everything. I mean, anything that is related to space is related to me. So even if it is something like biology, I did not opted, which I did not like study during my 11th and 12th grade, although I'm always interested to understand more. Then we also have quantum mechanics, because quantum mechanics is essential when it comes to space studies. So I'm also trying to give a head to that. I recently started reading this book. Its name is Something Deeply Hidden by
Sean
C.N.
Carroll.
Carroll. And
Yeah. Hmm.
yeah, so it's beautiful trying to understand much by that. It's also mind-boggling. Certain things are still complex for me, but it is beautiful. Like as I mentioned earlier, everything related to space is related to me.
Hmm. I'm thinking of reading Feynman for starting out in the
Oh
fields of
yes,
maybe
you should
quantum.
definitely.
Yeah, but
Right. If you
mhm.
consider Feynman, you should also consider Schaum's outline. It's a series of outlines where
I know
all the
I know
different kind
Sean
of
Carroll. I've seen a lot of his videos. A lot of his videos.
no, no, not Sean Carroll. It's outlines.
Oh, never
Schaum's
heard of it.
outlines.
Never heard
It's
of it.
it's
Hmm.
Yeah, it's a series of questions where we solve those questions with equations and all, like we do for our math and physics.
Hmm.
But those outlines are of all the different subjects which are not taught to us in our schools, like astronomy or biology, anything which has questions to which we can solve the answers for using equations. It's there, so it's pretty interesting. The Shaun's outlines. The spelling is Shaum.
Hmm.
Shaun's outlines.
S
Right.
Sechaun.
Chaums.
Oh, okay, right. So you said that you were working on relating neuroscience with astrophysics, right? Uh, Now
Right.
I have a question in my mind. Is there a possibility that maybe astrophysicists, and because you have been into it so much, that people are trying to relate our brain's entire function and our brain itself with the universe? Something so small
Right.
yet so complex with something so large and so complex.
Right. This is the fun with, microscopic and microscopic scales. Like
Hmm.
even if we are talking about classical mechanics and quantum mechanics, it is classical mechanics is all about studying the things at a macroscopic level, whereas quantum mechanics is about studying the things at a microscopic level. And it would be same about with neuroscience and astrophysics. But let us see how far we can get with that, because both the systems are extremely intricate, extremely complex. And I've just entered this because there's a lot that should be discovered. I believe I only know 0.1% of the entirety that lies out there. And perhaps when I discover something, we might as well have another podcast where we
Hmm.
talk about my research and my experience.
Yeah, sure. Why not? So I'll be moving
Right.
on with the questions that I have on my list.
Uh-huh, sure.
Why is the nature of particles on the quantum level so remarkably different from the ones on the classical level?
Right, that's interesting. So, talking of classical mechanics, It refers to the branch which deals with the motion of huge or giant objects. So it can be our cars, it can be anything that has to do with motion, that has to do with planets, that has to do with rockets, etc. And all the classical mechanics, or most part of the it is based on Isaac Newton's laws of motion and the law of universal gravitation. Now, we assume in classical mechanics that physical properties such as position, velocity, acceleration, or momentum can be measured and predicted with complete accuracy. But when we talk about the quantum level, which refers to the realm of physics that deals with very tiny objects at a microscopic level, it can be atoms, electrons, neutrons, photons, etc. And I believe at this level, the behavior of particles is described by the principle of quantum mechanics, which differs from classical mechanics at a large scale. And quantum mechanics also includes wave particle duality, superposition, and entanglement. We will discuss about all these three functions in detail. But these three components, like I mentioned, entanglement and superposition and wave particle duality, is what makes quantum mechanics very interesting, very fascinating, and at the same time, very, very complex to understand. Even scientists are pondering about many questions like how this might happen, and if this has happened, how, what is making it happen? We are still trying to discover. We are like scientists have also come up with the quantum computers, which are extremely capable of doing great things that we'll probably see in the next few years. Like in the recent days, ChatGPT has been a very good breakthrough. Something of that kind will come with, you know, quantum computers. Another important aspect that I like to put it here is about possibilism and determinism. Determinism means everything that happens in the universe is predetermined and governed by casual laws. So it means that all the events are like an inevitable consequence of prior events. For example, every action or decision made by a person is not a result of, let's say, his or her free will, but rather determined by external factors such as environment or the prevailing situations, etc. Talking like I'm taking this example to a human level, then we'll take it to classical mechanics and quantum level. And on the other hand, possibilism means that certain factors in environment may influence human behavior, or individuals still have the freedom to choose. Freedom is an important word which we'll use again for talking about electrons and all. So freedom to choose, their own actions and make their own decisions. So possibilism emphasizes the importance of free will, suggesting that we have the ability to overcome environmental constraints and shape our own destiny or shape our own reality, whatever seems to be possible. Now, taking into the consideration the microscopic scale, classical mechanics works on the basis of determinism, that is, all the things are already predetermined and everything is a consequence of what has happened in the past, whereas quantum mechanics works by the rules of possibilism. Another important aspect to this would be that particles on the quantum level occurs with the phenomenon of quantum entanglement. This means that it refers to the situation where two particles become linked in such a way that the behavior of one particle is influenced by the other or is related with another one. So even if they are separated by a large distance, they still are entangled in some way. Now, even I question how this must be happening, but we still haven't found answers to them. Like scientists are still wondering about that. I am still a little girl who is still studying about the aspects of the universe. And this is how it's been. Again, we have wave particle duality, that is, photons act like wave and particles too, which is which is another part of quantum mechanics. And regardless of the distance between any two particles which are entangled, the phenomenon of entanglement is not explainable by classical physics because, of course, classical physics is studied for different aspects. And the key feature to study such things, such minute things, is only possible with quantum mechanics.
Okay, there's a question that has sparked up in my mind. So you said determinism is mostly related with classical mechanics. You can determine what the particle, what an object, what a point sized object, whatever it is, will do in the
Right.
future. Uh, by calculating its trajectory, its motion, its distance from the origin, whatever. I mean, whatever mathematics you use. So the question that has up in my mind is that is there a concept of potential energy in quantum mechanics? Because what you said, I'm thinking of it like this. You're saying that determinism means that something is pretty pre-known. We can calculate it what it's
Right.
going to do in the future. That means everything needs to have a potential to do some form of work in classical mechanics. But
Right.
in quantum, you said it can't be determined. It's what was the term you
Right.
used for not for non
Determinism.
no after determinism.
Possibilism.
Yeah, possibilism. So in case of
Right.
possibilism, you said that it is not, we cannot calculate what it's going to do in the future. So yeah,
Right.
is there a possibility that maybe maybe the idea of potential energy doesn't exist in quantum mechanics? If you've read about it,
Right.
or
That's an
maybe
interesting
yeah.
question.
Hmm.
Yeah, yeah, yeah. But before that, I'd like to ask you that what do you think? Do electrons, photons, and all, do they contain energy?
Electrons, I mean, they contain energy just because of their motion, I would say, because they radiate it, or
Huh?
they release it when they change orbits, right? Uh,
Right.
Protons and
And
neutrons are
yeah,
basically in the nucleus, so they stay pretty static. They, I would say, definitely
right.
contain less amount of energy than electrons, though I don't know it yet. I mean, I'm just showing my intuition, but yeah, whatever the right
Got it.
answer is, I would like to
And
know. Mhm.
right. And what do you think about photons in the same manner?
Photons, I would mean, we mostly know photons in terms of moving particles, right? But if you're able to capture a
Move?
moving
Which
wave,
particles? Moving.
moving, yeah,
Yeah.
in motion,
Right, right.
because light travels
Mm-hmm.
at maximum speed, anything can travel at. So
Right.
I think, I mean, I've heard a lot about the concept of static photon, that you basically the mass is zero of a static photon, energy is almost zero, and then some people have also told me that the energy that a static photon contains is almost tending to be zero. I don't know. I don't know
Right.
the math behind it, but yeah.
Right. So, in this case, I believe that all the approaches that we have in quantum mechanics is probabilistic. See, possibility and probability are different, but talking about the potential of quantum particle, I believe it is a form of energy which cannot be localized in this space. Because when we talk about quantum mechanics, it is most related to all the things that are going on in space. And if we fuse potential energy with quantum mechanics, it can come up with something like the quantum potential energy. And just give me a moment. I
Yeah,
think
yeah,
I
sure.
have read it somewhere.
Sure.
Right.
Your camera
Yeah,
is
yeah,
off,
yeah.
by the
I
way.
remember.
Your
So,
camera is off, by the way.
oh, just let me check.
Yeah,
Is it on now?
now it's good. Yeah.
Right. Sorry for that. So, yeah, I remember. I read it. It was written by David Bohm, the scientist. He mentioned something about the quantum potential energy. Like, I'm glad you put that up so I can read more about it.
Mm-hmm.
And the energy at that level is not localized in space, and it is influenced a lot by the curvature in the space, by how much tightly bound the things are, and how much gravity influences all the things out there. So I
Mm-hmm.
think this is what it would be for your
The
question.
idea of gravity, I think, is mostly discussed by Newton in form of just something that exists because it exists, right? I mean, it's not because of some form of warp. He just mentioned it that some form of force exists that pulls everything towards each other, and it exists in everything that exists in the whole universe.
Yeah, right.
Though I think when I saw the videos of people simulating Einstein's theory of gravity, with these models of curved I think bowls and big structures, not technically
Right,
big,
right.
but I think half a meter or max to max 2 meters in diameter, and
Yes, right.
they were explaining Einstein's theory in that. And I mean, Newton's case was being used for everything in the same manner, that they were using a string and they were rotating it around from the center and the planet keeps on rotating no matter what the radius is. Though Einstein's
Right, right.
theory was different for every different kind. For example, if the object was big, uh, it had a bigger and deeper impact on the space time warp, and hence the particle had a greater radius around it, or maybe when the particle was closer to it, the speed of the particle
Right.
moving around it was faster in comparison to the one that was moving farther. Though for case of Newton, it was constant. I'm not denying Newton, definitely, and Newton is probably the one of the greatest scientists, or possibly the greatest scientist of our time, not just our time, but ever born almost, because he had almost no reference to use to study anything, and Einstein had a lot of things predetermined and pre-studied. A lot of people had given already a lot of theories, but yeah. So I think I only have a doubt over there. Like, why are we not studying force of gravity in terms of Einstein's theory too? Not just because it's quantum mechanics and school students cannot read it, or maybe it's too complex because of the math
Right.
behind it, but even just the theory.
Right, right. That's an interesting question, and it seems like you are pretty much engrossed in studying the different kind of projects that are there because you properly mentioned how we define Newton's and Einstein's gravity in different projects. Right. So the experiment that you mentioned, we actually used a fabric of spandex because spandex is very stretchable and that is properly attached to a circular bowl, let's say. And
Mm-hmm.
when we place a heavy object on in the middle of that spandex fabric, it acts as if it is the geometrical structure that we have out there in the universe, and that is how it keeps on working. That is how that experiment is being, portrayed for students in order to understand.
Mm-hmm.
See, talking about Einstein's general relativity, the theory, the fabric of space-time is a geometrical structure, like I said, and it is distorted by the presence of matter and energy. So the strength of this distortion is related to mass and energy content of the matter and energy that is present in space-time. And whenever we talk about Newton's like gravity or his theories or all the scientific calculations that he has made for us, it it makes it is a testament for us to understand that why it is so much necessary for us to go with Newtonian physics in order to understand what we are studying, because all the calculations that are there or all the equations that are there are properly gauged for studying whatever we study on a very Earth level.
Mm-hmm.
But when we go to larger dimensions, when we are talking about extremely bulky and heavy objects, which are extremely dense,
Mm-hmm.
which are so dense that they can warp the space-time fabric, I think it is essential to incorporate the equations and all the other ideas that are proposed by Einstein rather than Newton, because even the equations make sense. Like the greatest equations given by Einstein, one of them being E is equal to mc squared, which is sometimes said, like those who know it very well tell that it is only half, because that equation is also pretty dense. It is a very long one. And there are many things that are there different for space and different for Earth. So yeah, I think that is how it is.
Mm-hmm. Moving on, what is the I mean, I think it's pretty absurd to ask that, but what is the tensile strength of the fabric of space-time according to Einstein? Like, how massive does an object need to be in order to bend the fabric of space-time? I cannot, maybe, right? I
Right.
mean, no, I'm not massive enough,
Yes, yes.
but yeah, how massive? Like, is there a constant to it? Maybe a limit, a threshold? Mm-hmm.
Right. I really love talking about these scales, because before I explain this in detail, in this solar system of ours, like there's the sun and other planets, 99% of the entire mass of our solar
Yeah,
system
it's the
is
sun.
totally constituted
Yeah,
by sun,
yeah, yeah.
and rest of the 1% is distributed among the planets.
Uh-huh.
So this is how different things are. This is how interesting things are, and this is how the sun is able to
Mm-hmm.
put in so much weight on the space-time fabric that it is able to warp and put all the planets intact to it.
Mm-hmm.
Talking about tensile strength, I believe instead of calling it tensile strength, we should rather consider that the theory describes, like the Einstein's theory, describes it to be the curvature of space-time, which is again which is determined by the distribution of mass and energy. Like any object with mass or energy will cause a curvature on spacetime, but the amount of curvature it produces depends on the object's mass or energy content. So, in general, the larger the mass of energy content of an object, the more it will bend the fabric of spacetime around it.
Mm-hmm.
Whenever we do this experiment that the spandex sheet is attached to the bowl, the
Mm-hmm.
heavier object totally goes down, it sulks down
Mm-hmm.
in the center,
Mm-hmm.
and we put tiny marbles around it. So it really creates a very tiny difference, but it does create the difference. Like it is totally dependent on how much heavy that object is. And I believe there is no specific mass threshold required to bend spacetime. However, in order for the curvature of spacetime produced by an object to be detectable, like their weight should be enough to make themselves detectable. So yeah, the object needs to be significant enough with its mass or energy content. To give you an example, the curvature of space-time produced by the sun is detectable in the motion of planets around it, and the curvature produced by smaller objects such as individual planets or asteroids is so small that none of the objects around asteroids or planets are influenced. But talking of Earth, Moon is intact with Earth because Earth is heavy enough to keep Moon intact with it, and Sun is heavy enough to keep all the planets intact with it. Another favorite example of mine in this case would be the strong gravitational field of a black hole, which causes a significant curvature of the space-time fabric in its vicinity.
Mm-hmm.
That this curvature is so extreme that it is often described as a hole. Then that is how it
Yeah,
got
like it
its name,
tears
black hole.
tears the
So the
space-time fabric itself, right? Yeah.
Right, exactly.
Mm.
So the entire curvature caused by black hole is directly related to the mass of the black hole.
Mm.
And the more massive the black hole is, the greater curvature it produces. The last type or the biggest, the enormous type of the black hole is the supermassive black hole, which are so huge that I don't think we could ever imagine how large it must be.
Mm.
And scientists also say that, like, as every second passes, a new black hole is being created in the universe. And
Mm-hmm.
near any black hole, I mean the one which is very heavy,
Mm-hmm.
the gravitational field is so strong that it causes time to slow down completely and space to become totally distorted. So the curvature of space time is so extreme that it causes light to bend, like and distorted, leading to phenomena such as gravitational lensing and the formation of accretion disk around the black hole, etc. And in return, the concept of gravitational lensing is so helpful for all the astronomers or astrophysicists who study, because it really helps us to understand what all can be done or what all should be done to discover this and that. Because gravitational lensing kind of acts like a magnifying glass for us.
Yeah. Mm-hmm. Uh, so
Right.
like like you said that black hole is so massive. I mean, is it in terms of just size? Because a lot of times there are black holes that are almost the mass of the sun, but having the radius of a city, right? So does it density of the black hole of the object itself also matter, or is it just because of the mass and the radius of it?
Right, so density is mass upon volume, and
Mm-hmm.
it has mass, so it also has enough volume, which makes it very much bulkier, and that is how it is able to influence all the objects or all the particles around
But
it.
is it necessary?
I hope
Like
that
I
answers your
mentioned,
question.
right? But is it necessary? Like I mentioned, something can be the radius of a city, but have the mass of the sun.
Right,
I mean, we do have. I mean, such cases. Like we have heard of such cases. That a black hole is that
right,
of that low amount of size, but has that high amount of mass, and certainly its density is going to be
right.
so high too. I mean, you might also have heard of these very hypothetical terms that if how you can fit the whole humanity in a sugar cube, or maybe something like that. And
Extremely
yeah,
hypothetical.
yeah. So it's the same idea. So that's like, why does volume have to come into play then? I mean, if we are saying that volume of the or the size of it actually doesn't matter at times. Although I'll be moving to another black hole question that I have, but yeah. Mhm.
Yes,
Mhm.
yes, yes. Well, what is your take on this? I mean, it's interesting. So, why do you think volume is not necessary, or have you read it somewhere that volume is not
I've
necessary in
not
order
read
to
as deep
see
as
the
I've
formation of a
not
black hole?
read about it as deep as you might think. I have a
Right.
very shallow idea of it. Uh, I think in
Right.
fact
So,
in fact I
how
would
I
say
see
yeah,
this,
yeah. Mhm. Sure, go on.
Yeah,
Uh,
yeah, you may continue. I'll go after you.
no, I have a very shallow idea of it. In fact, I think if I
Okay.
start speaking, I would say something stupid. So let it be.
No, 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 it's okay. See, what my take is on this is that
Mhm,
matter is anything that occupies space, right?
mhm,
And volume is something which in which the particles are tightly bound, so there are no spaces in between.
mhm,
So I think that when something has to be so dense, like the point of singularity, it was so dense, it was tiny, but it was extremely dense, which led to all these different kind of things. Hence, I believe volume does play an important role because it eliminates all the other things. It eliminates vacuum, it eliminates the free spaces, and that is what makes the particles to be so tightly bound that there is no space between them, and that is what leads to the increased density of that entire object.
mhm. Okay. I usually listen to all of my
Right.
episodes on repeat. I actually don't grab everything right away in the episode itself, so I have to do it
Yeah,
do
yeah,
it
you
another
should
take.
take your
Yeah.
time.
Mhm.
Yeah, and I believe when you like re-listen to this one
Hmm.
again, you might as well come up with more questions, which would be interesting for
Yeah,
sure.
I have had a lot of astrophysics questions for a long amount of time. I had only one astrophysicist on my show.
Interesting.
I think, and
Who
that
was
was,
him?
I think his name was Swastik Chaube. Yeah. Hmm. I don't know if you know him.
Okay,
He's, I think, in Indian Institute of Astrophysics. He's studying there.
cool.
Hmm.
Right.
I think
Got it.
I mean it was pretty good of a good conversation. I felt really dumb.
Yeah.
So yeah.
Got it.
Mm, I'll be moving on to a question that I have from this book, Life 3.0.
Sure.
If
Let's
anybody
go on. Yeah.
wants to have it, I'm not putting a link in the description. So,
Yeah, it is
mhm,
recommended by me too
mhm.
because I did read the description and you also definitely give it a look.
Yeah, anyone who wants to read it, I have also already read it once. I have highlighted a lot of things, and I'm gonna read it probably sometime else. But yeah, so
Yeah.
I have this question related to if you know about the Chandrasekhar limit, right? Chandrasekhar limit says that anything needs to be 1.4 times the mass of our sun in order to undergo a cataclysmic thermonuclear detonation known as a supernova of type 1A, as it is mentioned over here.
Right.
Uh, the last time I got Swastik, the astrophysicist I was talking about a few seconds ago, uh, he mentioned that anything, if unless it is, I think, around 9 times the size of the sun, it can't be a black hole. My question over here is, if something can be a supernova, is it necessarily going to be a black hole or not?
Interesting. I believe it depends on the prevailing situations, like is the matter collapsing within itself, or is the volume or the matter inside that entire object, whether it is like sun or supernova, being so dense that it is able to influence everything that is to a wider range or that is near the wider range of that entire object. And this is the entire bulkiness of that object totally influences how it will be around it because I don't know
Mm-hmm.
what would be that number of radius where we cannot go near the black hole. We can only see it from a very far distance because these huge, enormous black holes they can influence all the things on them to a very very large radius to a very very large area.
Mm-hmm.
So in order for anything like supernova or sun to transform themselves into black holes, something and it must happen, which makes all the things collide or which makes all the thing evaporate or some different kind of fusion, some different kind of processes that should be occurring in that entire object in order to transform itself from supernova or sun to entire black hole. And
Mm-hmm.
our sun is not the
Yeah,
eligible
it
candidate
is not.
because though we think it's very huge and enormous, it is nowhere near to competing with the black hole.
Should we be glad that it is not an eligible candidate?
Yes. Yeah, although it would be what it is, like what we think
Mm-hmm.
it should have been,
Mm-hmm.
we still wouldn't exist, and the entire
Mm-hmm.
solar system would have a different
Mm-hmm.
name. So
Yeah.
it is what it is.
Mm-hmm.
Although it is pretty fascinating that every second a new black hole is being formed out there in the universe, and this suddenly gives us an idea of how vast our universe is, that we are still unable to imagine it clearly. And I also wonder that is it possible for one black hole to eat up another black hole? Like if one black hole is
Yeah.
bigger than the
Mm-hmm.
another one
Uh-huh.
and they're closer to each
Uh-huh.
other, so will that
I think
like
there's a
consume
video. I
another
think
black
there's a
hole
video
before
on
coming?
YouTube where they were simulating how a portal can go through another portal. There's a video on that if you've seen
Right.
it. Right.
And then it goes infinitely.
Uh-huh.
I think I saw this. I don't remember its name. And then
Yeah.
it goes infinitely.
Mm-hmm,
I
mm-hmm,
think so.
mm-hmm. I also don't remember the
Right.
result, what came out to be, but yeah, I remember the
Right.
thumbnail of it. It was a portal. What if a portal goes through another
Exactly.
portal? Yeah. All right.
Yeah, it's interesting. So
Mhm,
one question for you.
mhm.
Do you believe that anything such as portals exist out there, and if we pierce through some portal,
Mhm.
we'll discover some new world? What is your take on that?
I mean, I've heard of quantum tunneling, but the idea of portal,
Mm-hmm.
like, I've also read Doraemon. Anything, I mean, anything imaginable. I mean, if you're considering the universe to be in the sense that there's also this idea, if anything is imaginable, anything is possible. Then if something is not imaginable, it is not possible, or it is halfway through, something like that. And I think
That's right. That's very
if your
well said.
universe is of the kind that anything imaginable is possible, if there's a possibility that you have an Iron Man in your universe, then yeah, certainly, why not? Then you may have a Tony Stark, you may have another copy of RDJ, whatever you want. But yeah, I think that's the only possibility I can think of. If anything is imaginable, then maybe it is possible if we live in that kind of universe.
Right.
Though quantum tunneling, I think I'm very fascinated by that idea. I think if quantum
Right.
tunneling is possible, I think it's going to be a great catalyst to any some form of progress we want to make. Right, because if we are able to if we are able to skip a time frame or large amount of distance from one point to another point by traveling a really small amount of distance in the space time warp, I think that's one of the greatest achievements and one of the greatest discoveries we can have. But yeah, I mean, everything is a hypothesis. I can't really say much.
Yes, but it's fun to fantasize.
Mhm,
One thing I'd like to tell here, like the concept of wormhole,
mhm,
I mean, it's very fascinating that how two portals can come so close to each other that you'd be able to enter in one portal and go to the next one by eliminating a lot of distance. But I wonder how it'll happen, or when it'll happen, or is it even right to imagine that humans,
mhm,
which are so tiny, would have enough potential to make that happen? Because wormhole is entirely about taking two things to a level where the distance between them is eliminated and we can easily go from one place to another. It is fascinating, it is very complex, but this is just something I wonder about. And then this is the thing about astronomy and astrophysics. It is about different subjects as well,
mhm,
but we can imagine so much because there is never a limit to imagination. And sometimes when we enter that road or when we walk down that path of imagining things, it really helps in coming up with solutions sometimes. That I am an academic researcher and I have to write a lot of research papers, present abstract ideas to different people. So sometimes imagination really helps. It is like a crux at the pinnacle of all that we are researching, because this imagination is something that propels us to think in a way that nobody has ever thought, and everybody has a different approach in order to come up with a solution for a certain thing. So,
mhm,
imagination is necessary, and astronomy, astrophysics, or to be more generic, astronomical sciences give a lot of importance to
mhm.
imagination.
Certainly. So I have this big question in my hand. Uh, I think we're gonna
Okay, should I
get out
get
of time,
ready?
but don't think it really matters right now because as I said, this episode is going to be longer than other episodes because I had a lot of questions in my head.
Right.
But yeah, so I
Yeah.
read this sentence. I was reading, I think, an Olympiad book or something. The universe is expanding
Okay.
intrinsically, which causes a change in its size of space. It is not necessary for space to
Mm-hmm.
exist outside the universe. for it to expand into anything. So I think my intuition came into play, and then I think maybe I thought something like there's no need for extra space for universe to exist outside to what it is now. But I mean, maybe the
Right.
use cases are because we don't know what's outside, or maybe we don't know what if the universe has a finite boundary, and if it does,
Hmm.
it would have a volume.
What lies beyond that?
Yeah, what it would
Yes.
have a volume, but
Right.
it could also be the other way around, like no volume. Right, I mean, it doesn't have any form of volume because it doesn't have any boundary to it. This is kind of weird because if the universe does or doesn't have a volume, it still has objects inside it that require volume, right? Hmm.
Pretty
I
mind
think I
boggling.
mean I hope you are getting I hope I'm not sounding that stupid, right?
Yes, I
Mhm.
am. Yeah, yeah.
Does something need to have, so my question is, does something need to have a volume for something else to exist inside it that does occupies a volume? And I have a riddle in the end I will tell everybody, but yeah, I mean related to this. Yeah. Mhm. Mm.
Also, do they have an answer to that question?
I mean, you're asking from me, like if I have an answer to that question.
No, no, the
No,
book
it's
from
not
which you read the
actually. No, no.
paragraph. Do they?
That book isn't a mere Olympiad book. I think it had only multiple choice question, and it asked if it's true or false, if something like that.
I never have I ever seen such an interesting question in the Olympiad book. I have appeared for Olympiad exams too, but yeah,
Hmm.
let us answer this question.
Hmm.
So the question is pretty interesting that does an object need to
A
have
volume.
volume in order to make another things which it has to have volume?
Hmm.
Right. So for this, what I think is that though an object has volume or has not, it has matter.
Hmm.
And right, I thought you have a
No, no.
question. So everything that has matter, the matter or the collection of matter can be individualistic. And that individualistic matter or that series of matters or something that has matter tightly bound to it might have volume because those all the spheres or all the components become an individual entity. Hence, they might or might not consist of volume, which entirely depends on the prevailing conditions of that system.
Hmm.
But yes, it is quite confusing or perplexing that whether the entire universe has volume or not,
Hmm.
which depends whether it has boundaries
Hmm.
or not. But yeah, it is pretty much obvious to have for another objects to have volume because they do have their own mass
Hmm.
and matter,
Yeah, I mean,
right?
we only know the case where we know a random universe which might have a volume, maybe not, but we do know that it contains objects that require volume in it, right? I mean, I think
Right.
this is also the reason another question pops in the minds of scientists, that if the universe is expanding, what is it expanding into? It's also a question that I've heard a lot. I don't know. I mean, a lot of people, even who are
Okay.
not that much into astrophysics, but even when they have heard of this idea, they've come up with this question.
What do you think it should expand into?
Into something like it should have a limit to it. Is it is that what you're saying?
And why should it have a limit to it?
Yeah, I mean, I don't think it should have, to be honest. I mean, unless and until the idea of multiverse is something you believe in, I would not say. If the idea of if the idea of multiverse is something that you believe in, I think then in the idea of expansion itself should not be there, because I think if every other universe is expanding, they would
Hmm.
all start colliding into each other, right? After some point of time.
Right. I have two things here.
Hmm.
Let us just for an instance, let us believe in the bubble theory
Hmm.
and let us consider that our universe is a bubble
Hmm.
which is expanding. Like inside the bubble,
Hmm.
the entire universe is expanding. So will that bubble or the radius of that bubble will that expand
Hmm.
too? And will it like keep on growing and growing and growing
Hmm.
if our universe is finite inside the bubble but is also expanding?
Hmm.
Or will that happen that perhaps our universe, which began from a singularity, is expanding and we still have not reached to the end of that bubble so that the universe is still expanding, but perhaps it will expand so much one day that it will reach all the limits in the bubble and that bubble that bubble might pop out.
Mhm.
This is the case.
Is it the
But
idea of the
there are
big
multiple
crunch? Is it the
universes.
idea of the big crunch? What is it called?
Oh, there are lots of things in
Mhm.
that.
Mhm.
This is just something on top of my mind. There is big crunch, there is
Mhm.
big crunch.
Mhm.
There are many different
Mhm.
ideas like Big Bang, but those are all theories.
Yeah.
I mean, it is
Yeah.
easy to come
Mhm.
up with the theories,
Mhm.
but it is hard to explain something with a scientific
Mhm.
idea. Yeah, so coming back to the bubble,
Mhm.
so if our universe is the kind of bubble, there might be other bubbles as well. If we talk about multiple universes theory,
Mhm.
so what if all the bubbles expand so, like the internal matter in that bubble expands so much that all those bubbles pop out? So will that mean that our universe has ended, or will that mean that now that as that bubble popped out, the universe will have extreme limits to spread out?
Mhm.
So in science, every question has an answer, and every answer leads to a different question. So this is what I think. And in another thing, if we discard multiverse theory for a while,
Mhm.
I believe the universe, like our universe, keeps on expanding. But then the question arises: then where is another universe that is expanding, or even if it exists, then where it will be if our universe is so wide and expanding? Another thing could be that the entire thing, I know what to call that thing, the entire thing which consists of all the multiverses is so huge, is so enormous that it is able to accumulate all the bubbles, and it is also able to let those bubbles flow, let those bubbles expand as much as they want. A lot of questions arises if we just talk about multiverse theory and if we talk about expansion.
Mhm.
Although yet, like to the date, we do know that our universe's
Mhm.
expansion is being accelerated due to many components.
Mhm.
Right.
Okay, moving on with the next question that I have. Can you mention some books
Yeah.
for someone who wants to begin with astrophysics or the quantum world?
Interesting. Books are a part of me, and I do have a lot of books. If you like posting it somewhere, you might as well share the picture of all the books that
Uh
I
huh.
have. But first, let us go with Stephen Hawking. He is very popular. So I have a brief history of time. We don't need any context for why I have that
Mhm.
book. Another interesting book is The Grand Design.
Hmm.
I'd like to give a little short explanation about the Grand Design.
Mhm.
So Stephen Hawking's book, The Grand Design, is is a counter argument to the idea of God. So that book talks about the entire scientific explanation that disproves the entire thing of God. It says that God doesn't exist.
Hmm.
Not that I'm a religious person, but I am very spiritual. And I always wanted to know that if I need to know the God, perhaps if I study something opposite to that scale, that is something opposite to God, maybe I'll be able to understand God in a better way. This is a theory proposed by, I think, Herodotus. He is a historian. He said that in order to understand something, we must study the opposite scales of that. Like, in order to understand what is true, we must also study what is false. So, in the same way, this idea propelled me to buy the Grand Design, and I'm still reading it. So, it is an interesting book. Like, whether you believe in God, like whether you are a theist or an atheist, you should give it a look and try to understand that do you believe in do you believe that God doesn't exist or exist, but it is still something to crack your head with.
Hmm.
Another book by Stephen Hawking is The Universe in a Nutshell, which I have. Moving to another author who is very favorite of mine is Brian Greene,
Hmm. I've
and
heard
The
of it.
Elegant Universe, The Fabric of the Cosmos, The Hidden Reality are some of his books which I recommend, which I do have. For Sharon Carroll, of course, Something Deeply Hidden is the one that I have. Space, Time, and Geometry is a good one. And The Particle at the End of the Universe. So, for the questions that we have and for the questions that we'll keep on having in the future, this one is a really nice one to pick. For those who are in a hurry with all the hustle and bustle and studies and work, Astrophysics for People in a Hurry by Neil deGrasse Tyson is a good one. And yeah, I think that's pretty much it. But there are lots of books, a lot of them about which talks about infinity, which discuss about our existence, which talk about the entire cosmic scale.
Mhm.
But yeah, these
Mhm.
are a few that are top of my mind.
Hmm. Um, I, because you mentioned the idea of God according to Stephen Hawking. Well, like you said that you're a very spiritual person, but you're not exactly the believer in the idea of God. Like you don't imagine maybe an
No, no,
entity or
no.
something or what.
I said,
Uh-huh.
I am not religious, but I am spiritual.
Yeah.
I don't disprove God, but I am more willing to understand
I mean, you're
what
not
is
trying
God
to
and how.
sculpt the face of a man with a bow tie on his face or something like that, right?
Yes, yes,
Yeah.
right. Believe God is an
Hmm.
energy. Okay, coming to energy, we know energy just transforms from one body to another. It can neither be created nor destroyed. So that is what I think can be very much related or metaphrized with the concept of our soul. We believe we have a soul or a spirit, and we also know that our bodies are perishable, but our soul keeps on moving from one body to another.
Hmm.
So I believe soul and energy are pretty much related to each other. So this is how my scientific turn and spiritual turn come together and are helping me to understand how both the
So do you
things are
believe in
working simultaneously or at
yeah?
opposite
So
scales.
do you believe in reincarnation?
Reincarnation, yeah, that sounds interesting. I don't know if I believe or I don't, but I do believe that our soul, has a power, and perhaps it stores some information with it
Hmm.
that we are able to, understand something from the past life or something that soul holds is able to make us understand about what might have happened in the past.
Hmm.
Like some piece of information it might be consisting of.
Hmm. Although I think I read Stephen Hawking's last book. It was called "Brief Answers to the Big Questions." He finally,
I do have that one. Thank you for
yeah.
hinting.
So I think he mentioned it over there that God exists. I mean, he finally admitted that God exists for those who believe in him, on it. I mean, not technically him, but and doesn't exist for those who do not believe in it. But yeah,
Right.
I think he finally
So for
came
me,
up with that
yeah.
conclusion, and then he like it was his last book. Mhm.
Hmm, hmm, hmm. I think we always need something to believe in. Some believe in God, some believe in the power of nature, some believe in the universe, and I believe in three of these. So we always need something to believe in because what we believe in helps us or inspire us to keep on doing better, to just go with the life. And sometimes when life gives us a heartbreak or takes us on a roller coaster ride. So the things that we believe in help us to move forward. Inspiration is everywhere. It's in the nature, it's in the trees, it's in all the natural components, it's in the universe, it's everywhere. Hence, having something to believe in, like if those are our parents too, sometimes whom we consider our God, or if it's the universe or the whole power that surrounds
Mhm.
us, yeah, it's all that we believe in.
Mhm.
Right.
Uh, the next question that I have, yeah. So Einstein found a loophole in the equation of the force of gravity exerted by two bodies onto each other. What he found was that Newton's equation said that force of gravity equals g times mass of object 1 times mass of object 2 by the radius between the two objects, the square, makes the speed of gravity equal to
Right.
that of light. I would love to know your take on this, because then he also said that the if one of the masses get out of the equation, the force of gravity becomes zero,
Hmm.
like instantly, right? It happens instantly, or like
Right.
at the speed of light. Uh, in fact, I think faster than the speed of light, because when light takes 8 minutes 20 seconds to come from Earth to the sun. But yeah, I would like to know what's your
Yeah.
take on this.
It does like light takes light does take some time to come from sun to the
Hmm.
earth, but the speed of light that is at its own scale is pretty much it's pretty
Hmm.
vast. So talking about the loophole, I don't think Einstein found a loophole.
Hmm.
He rather took Newton's equation for gravity into consideration, and he developed a new theory of gravity called general
Yeah.
relativity that we
Hmm.
know by the name
Hmm.
today, which fundamentally changed our understanding of of gravity. So the equation that you mentioned, which is again given by Newton, the force between two masses is given by the thing that you said, and g is the gravitational constant, like we know. So when the mass of object one and mass of object two are the masses
Hmm.
that we take into the consideration for the entire equation, and r is the distance between them. This equation that the force of gravity propagates instantaneously through space, which is inconsistent with the fact that nothing can travel faster than the speed of light. I hope that makes sense to
Mhm.
you. And in general relativity, Einstein showed that gravity arises from the curvature of space-time caused by the presence of massive objects. So the motion of objects in a gravitational field is determined, let's say, by the geometry of space-time, which can be described using a set of equations known as the Einstein's field
Mhm.
equations. And these equations predict that the speed of gravity is equal to the speed of light, which has been confirmed by some experiments and observations. Like I believe I have sometimes read in the entire journey of me reading books. But yeah, that is the case. But of course, when we are talking of gravity, we do need two objects in order to make gravity happen, in order to show that gravity really exists over there.
Mhm.
There are a few differences between the gravity or the ideas of gravity proposed by Einstein and by those which are proposed by Newton. But let us say that the ideas Einstein developed were on the basis of Newtonian gravity, because, like you said, Einstein had a lot of resources, whereas Newton did not. But Newton's equations did help Einstein, let us agree, to come up with something new and in order to understand perhaps the universe in a better way.
Mhm. Yep. So, moving on, uh, I would love to know what you've been doing with your organization, Seeking Space. Can you introduce it to the audience?
Right. My website, seekingspace.in, is
Mm-hmm.
a beautiful place for me. I built it with a lot of love, compassion for all of you who would like to read the articles that I've written. Like some of the primary articles are about what is astronomy, uh, and why astronomy. Like why did I choose astronomy? And one of the sentences that I like to quote is that I did not choose this subject, rather the subject, like the astronomy or the universe, chose me for studying it. And this is what I believe. With the articles, it also has some blogs about 3D, about additive manufacturing,
Mm-hmm.
and about a lot of things and space tech and advanced space solutions.
Mm-hmm.
I also write some poems which explain scientific ideas in a poetic way that gives a creative turn to it. And there are a lot of things over there as well. Along with that, I do have some videos on YouTube. Lately, I haven't been active because I was deeply engrossed in my research work and the projects that I'm currently up to. But yes, you might as well discover my website, my Instagram, my LinkedIn. I have a lot of things to share. Would
Mm-hmm.
be coming up with some interesting things again. Would like to explain my research ideas, my research papers, my abstract ideas, my take on spirituality and the universe and the beautiful idea of how souls are there and the beauty of the universe. And through seekingspace.in, I really want people to understand or to be able to admire the astronomical sciences, because this is not just about studying but getting so much into it that I bath in those subjects. I am completely soaked in those subjects that everything about me every day when I wake up, there is nothing to do except for studying, reading, and understanding these things that are there out there. And I don't necessarily take this as a responsibility or as some source of income or some source of earning a degree. It is rather pure compassion, pure admiration, pure love that I have towards this subject. And this is what has helped me to be able to go with the subject and choose this as something that I'd be pursuing for the rest of my
Mm-hmm.
life.
Yeah. Uh,
Right. So this is,
yes, continue.
this is my
Mm-hmm.
website, but I'm also actively working as a leading member in different organizations. To name a few, the Nebula Space Organization, or Academic Journal, Space Aura, Geoxtem, and a few.
Mm-hmm.
Yeah. So I'm working with them. I believe that alone I can go faster, but together we can go farther. And when I take all the people with me, we all have a common mission, a common goal of taking all the people together, making them understand the beauty of this subject and discovering new ideas, coming up with something that hasn't been discovered yet, or perhaps creating some innovative solutions or some sustainable solutions to the recent development or to the recent missions, etc.
Mm-hmm.
So this is how I'm taking all the people along with me. I am into many organizations. Some of them I cannot recall at the moment. I'm also working with some individuals who someone like one of them has an AI company. Another one among them is like total into biotechnology. But all these ideas, when come together, they create something new, they create something very extraordinary. And I believe in the upcoming years, India would be at the top level for all these subjects. Currently, all the things that we have, like even our space agency, is a bit underrated,
Mm-hmm.
but we all, as a future of our
Mm-hmm.
nation, as the youth, are trying to bring
Mm-hmm.
India to a better level and to show the world that we are really capable of doing what we think or what we imagine of.
Um, yeah, I would like to also talk about this thing that, I mean, a lot of people have talked about this a lot, that India has the youngest population, on average in the whole world.
Exactly.
I think
Right.
Africa has a better and younger population because it is more underdeveloped than us. uh, I think the demographics go that way itself. The most underdeveloped countries have the youngest of populations, and then over time, the most developed ones have their average populations in around mid 30s, maybe 40s. Like Japan has in
Yes,
40s, I
right.
think. I guess I don't remember. Hmm.
Right. So this is, yeah, yeah. So sorry, you may continue. I'll go
Yeah.
after you.
So like, uh, my question really is that, uh, India's youth, technically, I would say, is pretty much. I feel it. I mean, I've also not. I'm not. I do not even feel it. I see it almost around me too. It's almost directionless. Like they have a lot of potential, certainly a lot of energy. You know,
True. Mm-hmm.
because they are young, and certainly they are going to be there for a longer time than people who are definitely older. But I
Right.
don't really feel like their direction. Like they don't seem to have, a lot of them mostly, I would say, they don't seem to have a goal or a purpose to fulfill a lot of times. And a lot of people find their purpose and their goals very young. A lot of people don't. In fact, some of them find it in even in their late 20s, maybe 30s, something. uh, asking you, like, what could be the possible solution to, not just, because not just we have a pot, it's like having a lot of magnitude but almost no direction. It's a scalar quantity, it's not a vector quantity. So in order to, if
That's
yeah,
very well
yeah,
put.
if do you have like any possible solutions to like bringing all of this potential into one place and making it work? Because I think there's a lot of
Right.
population
I
that is not having any form of, working going on.
True. Right.
Mm-hmm.
I'd like if you add your opinions to this answer as well.
Mm-hmm.
I believe that India is mostly driven by the old age mindset. Hence, people often, like those who are limited with the resources, do not have enough help, self-help, or help from the outside, or even the inspiration which would help them to think beyond their limits and to go and really take some risk and do something that the entire world is doing, do something extraordinary. We don't have direction because we are totally driven by the oldest ideas. We are not ready to come up with something new. Why do you think most of the young generation, like 12th or 11th graders, go with like engineering exams and medical exams, and why never they say that I want to pursue a career in astrophotography or astrophysics or something, as something like history or something entirely different, something like studying the fossils and all? No, because we are totally dependent, or we are total, our perception is tainted with the ideas of what others would think, or is it really going to help me, or is it financially a good idea? When I was about to step in this entire realm of astronomy, the elders would say, I mean, even the students being the students themselves, that astronomy is good as a hobby, not as a career. It won't bring me much money, but this isn't true. When I entered my step into this, I really understand that there's a lot that can be done. And yeah, income is important, and a lot of sources can be developed by that, because at the end of the day, it is totally dependent on our skills. But when we are totally passionate about studying something, we should definitely give it a try. And when we love it so much, we definitely find options. So whether it is making money with that or doing anything that we would like to do with that subject. So in order to get the proper direction, we must be able to understand ourselves better and should be able to break the paradigm that exists out there, to break the misconceptions. and to clear our vision, to clear the tainted perception that we have of humanity today. One more thing that I like to add, you know, in the entire world, only 28 or 30% of women are there who pursue astronomy as a career. And this is like there are a lot of problems due to which this ratio is so down and this ratio is so low. There are a lot of problems which are related to sexual identity or any of those things, or the resources, or let's say we take an example of East India, the eastern countries in sorry, the eastern states in our countries. They really have so limited options, and we don't see them out there, like the connections with North India or South India or the Western India is so well, but we don't really have good connections with East India.
Mhm.
So all the youth should come together, or even if they're individuals, should break the paradigm and really take a broader look, should be able to have a broader view about what really can be done and why are they still holding themselves from stepping to the big world and from contributing to the
Mhm.
change.
Um, to be honest, I think uh, what I think is that, for example, as you said, the representation of women is very low in STEM education, right? Though I think it has
True.
I think in mostly Western countries too, it has been way greater for
Quite.
arts and humanities. In fact, I think it's better than men and male students, male category students. Uh,
True.
and I think what you're saying, that the representation of all these states also, in the western side of the and in the eastern side of the country, have a very low amount of participation in country's progress and towards its development. I think I don't know, but it's quite surprising to know that even Bangladesh has a higher working population of urban women than India. China, I think it's in fact 90% or something. So that's pretty good. Like only 10% of women are not working in the urban areas. They are housewives, or
Right.
maybe they are just not working. Maybe anything. I just don't want to get into personal stuff. But for India, it's only 6%. In fact, it has dropped, I think, to 5 point something. I don't really remember. Yeah, because I'm not really good at
Right.
memory, to be honest. But yeah, I think it has dropped even further. And to be honest, I think the only problem here is because I don't think the government has done something. Then I mean, the government has not worked on it. Like for example, Beti Bachao Beti Padhao has been very prominent. In fact, when I think it was International Women's Day a few days ago, right? I saw a lot of posters, a lot of banners moving around uh, about women empowerment. But I don't know, like, how is this not working? Like, for example, awareness is something else. Like, there's soft power. Awareness is soft power. It's like you're just trying to maybe implicate something into somebody's mind. Hard power is basically like you're coming and you're just implementing it right away. Maybe if the prime minister gives a talk on, what is his talk called?
Pariksha pe charcha?
Yeah, no, I mean, not pariksha pe charcha. I mean, pariksha is pe charcha is, I think, only happens once a year and only for examinations. So,
For
yeah, only
students.
for
Yeah.
students. I think it's what is it even called? I don't really remember.
Man ki baat.
Yeah, man ki baat. Yeah, exactly. So I mean, I think these things rather need some moment of hard power. Like if people see maybe the prime minister talking about these things, maybe something might happen, because I think Prime Minister
True.
Modi doesn't have just a voter base; he has a fan base. Technically, people are mad behind him almost. But yeah, I don't want to get into political stuff. Uh, yeah.
Mhm.
Finally, any message for our audience?
Right. The thing that you mentioned,
Mm-hmm.
I'd like to tell you
Mm-hmm.
that there are still some parts in our
Mm-hmm.
country, in Rajasthan, in Madhya Pradesh, Uttar Pradesh, where the society is driven by the male
Mm-hmm.
mentality. And that is where the things come into
Mm-hmm.
play. Because let's say some women might have some dreams and would like to work or would like to things that they want to do, but then the society is driven
Patriarchal. Yeah.
by the male perceptions and by
Mm-hmm.
the entire
Mm-hmm.
mentality. It's really hard for women to, go what they and do what they want to do. Because in such country, in such places, If the society is driven by a male mentality, their decisions are also, driven by what their fathers or what their husbands or their brothers or the elders or the male would
Mhm.
say. I think this is one of the problems. I mean, of course, there would be a lot of them, but this is one of them, and that is why they are unable to have that approach towards hard power. Be aware, getting aware, like having awareness is a different thing, but being able to step out and do such great things is a
Mhm.
different thing. I am able to do that because I get a lot of support from my school, from my parents, from my family members, from my friends, and the online community that I have. But what if someone doesn't have all of this? He or she would have to start from scratch, and if no one is supporting, it would be really hard. So
Mhm.
this is the root cause, I
Mhm.
think,
Mhm.
especially in such
Although
places.
I don't know if you've heard of the story of that North Korean woman who escaped from North Korea and came to China, and then yeah,
I think I did.
yeah, and I think that was very really inspiring. Uh, that I think she
Right.
also became very popular after she went on Joe Rogan's podcast. She was also on Flagrant. I don't know if you know it. If that's also a podcast, but yeah. So yeah, finally, any
Got it.
message for our audience?
Right. Message for audience. I want you to always seek out for help. There are a lot of things available. I mean, you can also reach out to me if there's anything that you're struggling with, be it your studies, be it your dreams, be it your degree, be it your job, anything of that kind. We should be able to reach out to others whenever we need something, because today the online community that we all as an individual or as a group are establishing everywhere, especially in India, is really helping us to create an impact on each other's life. And I really want you all to understand that. Rather than that, if there's anything that you're willing to ask me, you may. There are different handles that you can access, like LinkedIn, Instagram, and anything of that kind. And on top of that, if you really need some help for, like, I mean, this would be quite weird, but if you need some help for convincing your parents that what you're doing is right, like if you believe what you're doing is right, you can always reach out to us. We would be there to help you. And there are a lot of different things. I want you to understand the beauty. I want you to look at the beauty of every subject before you actually start reading it or understanding it or learning it. And sometimes unlearning something in order to learn something in a better way is again extremely essential. On top of that, do not always be driven by the grades, by the merit. It is very important for us to be more innovative. Sometimes the students with really great grades are unable to answer simple questions like what does a rectifier do or how do the LEDs work. This isn't the real knowledge. This is a tradition that has been occurring in our country, that is rote memorization. But today we need to break all the shackles that were holding us back, and that and the education system, or not the education system, but the things or the situation around us which forced us to go for the rote memorization.
The absolute
Today
theme of this
we need
podcast
to
itself,
innovate.
yeah.
We need to
The
learn.
absolute theme of this podcast is
Yes,
also similar. It's to promote
right.
unconventional education in and especially in the areas of space and science, and not just rote memorize stuff and
True.
all. If in fact that's why I think you see that I don't really mention a lot of terms in my when I'm asking questions, because I don't really remember much. I don't have a great memory, but
Right.
yeah, whatever concepts I have, I really like to keep them in mind. But yeah, yeah, you can continue.
True. Right. And then another thing is that as far as you're curious, you are alive. If you're not curious, you're like half dead. Hence, be curious, keep seeking, keep exploring. This is the tagline of my website, and this is also the official message which I mostly give to others. And yeah, do not hesitate from reaching out to gain more resources, to get any sort of help. We are always there. And if you have any questions regarding this podcast, you may ask me. I'm always eager to answer your questions, or is anything that I can help you with. I definitely love. There are more books that you might read. I'd like to show you a few. This author, Dr. Saket Chattopadhyay, sent me his book, The Mastery. It's a novel. Maybe you consider reading this. It's a very interesting one. Another thing, this
Yeah,
book,
the Republic.
The
Mm,
Republic by the
mm,
Plato, which is really a beautiful one that I'm currently reading. And another book that I recently ordered is this one by
mm,
Oscar Wilde, which is again very interesting. So I have philosophy, I have science, I have fiction, I have space, I have quantum mechanics, I have
Mhm.
everything that I need to keep filling
Mhm.
my mind, and this is what you should be doing. Now, I do get that not all of you might be an avid reader, but it's not if you're not someone who likes to read, you might be someone who likes to
Mhm.
listen. So this is the medium for you. If you don't like both, if there's something else that you really need in order to make yourself learn something, try to find your ways because different things work for different people and you should always keep on finding
Mhm.
your way. I think that's all
Mhm.
for the day.
And yeah, you had an announcement to make.
Oh,
Mhm.
yeah, yeah, right. So, when will this podcast be out? Like, out for the
Um,
audience?
Most probably Tuesday. I think yeah, it should be out on Tuesday. At least the audio
Tuesday.
will be out on Tuesday.
Right,
Maybe not the video yet, but yeah, because we have not even prepared for anything for
right.
the video. In fact, the YouTube channel is also not created, so I think that's going to take time.
Okay. I hope you'll figure it out. Yeah, the announcement
Mhm.
is that in Bangalore, like at IISc Bangalore, we are hosting an event, Cosmo
Mhm.
Expo, which consists of lectures by renowned professors. One of them is an Indian scientist, and even I am invited at IISc Bangalore to deliver a lecture, which would be something about empowering women in STEM and also the importance of S in STEM, which is going to be very interesting. And that is the entire those lectures are followed by a stargazing session. We would have a lot of astronomers with their telescopes, huge telescopes all the way underground with different binoculars. We'd be taking you on a ride to the cosmos, and it would be wonderful indeed. So I do understand that people from different states might not be able to come, but if you live in Bangalore, if you live in Karnataka or in the southern part of our India, you should definitely come. The event is scheduled on 1st of April, yeah, this year, and it is suitable for the ages 14 and above. So do come, like if you are high school senior, high school junior, or even if you are an undergraduate, you are cordially invited for the
Mhm.
event.
Great. Anybody who lives in Bangalore or is planning to visit, certainly try to go to the event.
Should not
Mhm.
miss. Yes,
Uh,
right.
yeah. So I think we have come to an end of our show. I was thinking. I mean, I'm not going to talk about this on
Hmm.
the show. Okay, I'll turn the recording off and then I'll be talking about this. Yeah. So thank you everybody for listening to another episode of the Wimp podcast. This was really fun. Definitely one of the longer ones. How many minutes has it been? Uh,
Probably more than an
uh-huh.
hour.
1 hour 15 minutes. Yeah. So uh so thank you for listening to another episode. Hope to see you next time. Probably this will be the first video episode of our show too. And yeah, keep looking up. Bye.